Not long ago, most people thought humanoid robots were still decades away from being useful. They looked impressive in laboratories, but they couldn't really function in the messy, unpredictable environments where humans work every day. Engineers could make robots dance, jump, or perform carefully scripted tasks. But the moment something unexpected happened, the machine would freeze or fail. But something unusual has been happening in robotics over the last few years. These machines are no longer just performing controlled demonstrations. They are starting to enter real workplaces, real factories, and real testing environments. And as that happens, we're beginning to see both the incredible potential of these machines and the unexpected problems that come with them. Recently, during a robotics demonstration, something strange happened. Engineers were testing a humanoid robot designed to interact with objects in a workspace. The robot was performing a simple task, picking up objects and moving them across a table. At first, everything appeared normal. The robot followed its instructions, moved its arms smoothly, and completed the task exactly as planned. But then the machine suddenly behaved in a way the engineers did not expect. Instead of continuing its programmed routine, the robot made a sudden movement toward the engineers standing nearby. The motion looked aggressive and unplanned, forcing the engineers to quickly step back to avoid the machine's arm. Nothing dangerous actually happened. The robot was quickly shut down and no one was injured. But the moment raised an important question that many experts in robotics have been quietly discussing. What happens when machines powered by artificial intelligence start behaving in ways their creators didn't fully predict? Incidents like this don't mean robots are becoming evil or dangerous in the way science fiction movies portray them. In reality, most robotic malfunctions come down to technical issues. Sensors might misinterpret an object, software might receive incorrect data, or an unexpected movement in the environment might cause the machine to react incorrectly. But as robots become more complex and more autonomous, the challenges engineers face become far more complicated. This moment during the demonstration highlights something fascinating about the future of robotics. We are entering a time where machines are no longer just tools that follow strict instructions. They are becoming systems that interpret information from the world around them. And sometimes interpretation can lead to unexpected outcomes. Despite moments like this, the robotics industry is moving forward faster than ever. Some of the world's largest technology companies are investing billions of dollars into building machines that can walk, move, and work alongside humans. One of the companies pushing this vision the hardest is Tesla. The company revealed its humanoid robot project called Optimus as part of its long-term strategy to expand beyond electric vehicles. The idea behind Optimus is simple but incredibly ambitious. Build a robot that can perform repetitive physical tasks that humans currently do. Tesla engineers believe the same artificial intelligence systems that power the company's self-driving technology could eventually control humanoid robots. Instead of guiding a car through city streets, those AI systems would guide a robotic body through a workplace. Early demonstrations of the Optimus robot showed it walking slowly and carefully across a stage. Critics initially dismissed the robot as little more than a publicity stunt, but over time, Tesla began showing more advanced demonstrations. The robot could sort objects, lift items, and perform simple tasks in controlled environments. While these abilities might seem basic, they represent important progress. Walking robots must constantly balance themselves while processing information from cameras, sensors, and motors. Coordinating all of those systems at once is an enormous engineering challenge. But Tesla is not the only company racing to build humanoid robots. Another company making headlines recently is Figure AI. Their humanoid robot, called Figure 01, is designed specifically for industrial environments like factories and warehouses. What makes this robot especially interesting is how deeply it integrates artificial intelligence into its design. Instead of relying only on rigid programming, the robot uses advanced AI systems to understand objects, interpret instructions, and perform tasks more flexibly. In demonstrations released by the company, The robot can identify objects on a table, pick them up carefully, and place them where they need to go. These may seem like simple tasks for humans, but they are incredibly complex for machines. Every object has a different shape, weight, and orientation. A robot must analyze all of those variables before attempting to move it. One mistake could cause the robot to drop the object or lose its balance. The integration of artificial intelligence into robotics is changing how these machines operate. Traditional robots are extremely precise but limited. They perform the same motion repeatedly in controlled environments. AI-powered robots are different. They can adapt to situations that were not specifically programmed. For example, if an object is slightly out of place, the robot can adjust its movement. If the lighting changes or the environment shifts, the robot can still interpret what it sees and continue its task. This ability to adapt is what many experts believe will unlock the true potential of humanoid robots. Another company that has spent years pushing the boundaries of robotics is Boston Dynamics. Their humanoid robot Atlas has become famous online for performing impressive movements that once seemed impossible for machines. Atlas can run, jump, and even perform backflips. Videos of the robot navigating obstacle courses have been watched millions of times across the internet. While these demonstrations are visually impressive, they also represent serious progress in robotics engineering. One of the hardest challenges in building humanoid robots is balance. Humans maintain balance naturally through a complex system of muscles and reflexes. Robots must recreate that ability using sensors, motors, and sophisticated control algorithms. If a robot loses balance while walking, it can easily fall. That's why early humanoid robots often move slowly and carefully. Atlas demonstrated that robots could move dynamically, adjusting their posture and balance in real time. These breakthroughs are now influencing many other robotics companies developing humanoid machines. But while companies are racing to build more capable robots, engineers are also working to solve another critical problem: safety. Machines that operate around humans must be extremely reliable. A malfunctioning robot in a factory or warehouse could cause serious damage or injuries. That's why incidents like the earlier demonstration moment are taken very seriously by engineers. Every unexpected movement is carefully analysed to understand what caused it and how it can be prevented in the future. Robotics teams use extensive testing to make sure their machines behave predictably. They simulate thousands of scenarios to see how a robot reacts to different situations. Sensors monitor everything from the robot's joint movements to the objects around it. If anything unusual happens, safety systems can immediately shut down the machine. These safeguards are essential as robots begin moving out of laboratories and into real workplaces. Because that transition is already starting. Some companies are now testing humanoid robots inside factories and warehouses to see how they perform in real conditions. Instead of carefully controlled demonstrations, these robots are exposed to unpredictable environments where objects move, people walk around, and tasks constantly change. These tests are incredibly important because they reveal problems engineers may not have anticipated. Sometimes the robot works exactly as expected. Other times, unexpected issues appear. But each test provides valuable data that helps improve the machines. The goal for many robotics companies is to eventually build robots that can handle a wide variety of tasks. Imagine a warehouse where robots can move packages, transport materials and assist human workers. Instead of being fixed to one station, humanoid robots could walk freely through the facility performing different jobs throughout the day. Factories could become more flexible and efficient. Dangerous tasks in construction or mining could be performed by machines instead of humans. Even hospitals might one day use robots to transport equipment or assist medical staff. But there is also a deeper question behind all of this progress. If robots become capable enough to perform many types of work, what happens to human jobs? Throughout history, automation has changed the workforce many times. Machines replace certain agricultural tasks, Industrial equipment transformed manufacturing, and computers reshaped office work. Each wave of technology created new industries, while reducing the need for certain types of labour. Humanoid robots could represent the next wave of automation. Jobs that involve repetitive physical work may eventually be performed by machines. Warehouse sorting, basic assembly tasks and material transport are all potential areas where robots could be used. However, many experts believe robots will initially work alongside humans rather than replacing them completely. Humans are still far better at handling complex situations, solving unexpected problems and making decisions that require judgment. Robots excel at repetition and precision, but they struggle with creativity and flexible thinking. In many workplaces, the future may involve humans and robots collaborating. Robots could handle physically demanding tasks while humans focus on planning, supervision and problem solving. But the pace of technological development will determine how quickly that future arrives. Right now, the robotics industry is advancing at an incredible speed. Artificial intelligence is improving rapidly. Sensors are becoming more powerful and affordable. Robotic hardware is becoming lighter, stronger, and more efficient. And as these technologies combine, the capabilities of robots continue to grow. Just a decade ago, a humanoid robot performing basic tasks would have seemed extraordinary. Today, multiple companies are building machines that can walk, carry objects, and interact with their environments. And the progress is accelerating. Each new breakthrough brings us closer to a world where robots are no longer confined to laboratories and research facilities. Instead, they could become part of everyday life, working in factories, assisting in hospitals, helping transport goods in warehouses, perhaps even assisting people at home. But as the earlier demonstration incident showed, the road to that future will not be perfectly smooth. Robotics is one of the most complex engineering challenges humanity has ever attempted. Every new capability introduces new challenges. Every new test reveals new problems. But with each obstacle engineers overcome, the technology moves forward. The robotics race is no longer just about building machines that move. It's about building machines that understand the world around them. And once robots truly understand their environment, their potential could be enormous. The machines we are seeing today may only be the early prototypes of a much larger transformation. A transformation that could change how industries operate and how humans interact with technology. Because the future of robotics is not just about machines. It's about the relationship between humans and intelligent systems. And right now, that future is being built faster than most people realize. The next decade may determine whether humanoid robots remain experimental machines or become one of the most important technologies ever created. And judging by the pace of innovation, that moment may arrive sooner than anyone expected.